Disjunction says if both the statements are false, then it is false. In all the other cases, it is true. 2 plus 5 is equal to 6, or all integers are rational. So whenever you come across the word or, it is nothing but disjunction. When you come across if and then statement, it is clearly a conditional statement. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. So we were studying about the mathematical logic, principles of reasoning. So in our previous session, we have studied what do you mean by proposition. A proposition is a statement which is either true or false, and we have learned how to write the truth values also, and we have learnt about all those logical connectivities: conjunction, bijunction, negation, conditional and biconditional. In this session, we are dealing with the same logical connectivities. We are trying to write the statement in the form of those logical connectivities. So let's see now. Symbolize the following propositions. First one, 2 plus 5 is equal to 6, or all integers are rational. So whenever you come across the word or, it is nothing but disjunction. So therefore, we can take this statement as P or as disjunction symbol and all the integers rationals as Q. So this is how we can symbolize using the mathematical logic. The second one, if two triangles are similar, then their corresponding sides are not proposition. So here you can see we are using the word if then. So where we come across if then type of reason. If P is true, then Q is, like that. So where we come across such type of implications. So it is implying the second statement using the first statement. So where we come across P implies Q, that is the conditional statement. So therefore here P should be the statement two triangles are similar. P must be considered as two triangles are similar. And the Q must be considered as corresponding sides or not proportional. So where we come across such type of connectivities, that is P implies Q, which is a conditional statement. So therefore, for this question, this is the answer. P implies Q. Or you can write this symbol also. P implies Q. This is also the correct answer. Next one. If a quadrilateral is a square, then it is a rectangle. Again, we are coming across the if-then statement. So here, a quadrilateral is a square must be considered as one simple statement P, and it is a square, it is a rectangle must be considered as one more simple statement Q. So therefore, we will write P implies Q. So this question symbolizes the conditional statement P implies Q. Next one. 3x is equal to 9 and x less than 7. So 3x is equal to 9, we can consider it as one simple proposition P. X less than 7 can be considered as one more simple proposition Q. Since we have a connective and, where we use the word and in conjunction. So therefore, this can be symbolized as P and Q. So this is the symbolization of the given statement. Next we have if two numbers and, so this is considered as a R. If two numbers are equal, then their squares are not equal. So maybe my first statement is true, second statement is false, but when you come across if and then statement. It is clearly a conditional statement. So we take two numbers are equal as one statement, squares are not equal as one more statement, that is Q, where P implies Q. So a conditional statement. Next one, if oxygen is a gas, then gold is a compound. Again, oxygen is a gas is one simple proposition. Gold is a compound, one more proposition. We are connecting with the words if, then. So therefore, it is a conditional statement. P implies Q. Next, we come across the second type of question. If the truth values of the proposition P, Q, R are true, true, false respectively, then the truth values of the following compound proposition. So they have given P has a truth value true. That means P is true, Q is true and R is false. So we have three simple proposition considered as P, Q, R, where P is true, Q is true, R is false. We have some logical connection here between all the three terms. We have to verify it whether this connectivity is true or false. Let's see now Q or R. So here let's see Q and R. Q and R. So Q is true, R is false. This is the symbol for disjunction. Disjunction says if both the statements are false, then it is false. In all the other cases, it is true. So therefore, here we have true, false. Therefore, Q or R is true. So therefore, this is true now. Now we got P is true. And the statement Q or R is true. Now we have both are true, but we have a conditional between these two. What does the conditional statement says? If P is true, Q is false, then it is false. In all the other cases, it is true. So here P is true, the second statement is not false, it is true only. So therefore, this will be a true. So therefore, what is the truth value of this compound proposition? True. So this is a true statement now. Next, we come across one more proposition. Remember, given P is true, Q is true, R is false. Let's verify this logical connectivities. We have P and R. P and R. So what does AND says? If both are true, it is true. In all other cases, it is false. So we have P as true. So P is true and R is false. So therefore, P and R will be false here. So now we have to combine with the Q here. So we have Q as a true. So what is the statement now? P and R or Q, which is a disjunction property. What does the disjunction says? It is false when both are false. In all the other cases, it is true. So here both are not false. So therefore, it must be a true statement. So therefore, the answer for this is true. Next question. P or negation Q implies R. So we have P true, Q true or false. First, let's see negation of Q. So Q is true. So therefore, negation of Q will be false. Now, P and negation Q. So when this is true. So this is true when both are true. In all other cases, it is false. So clearly P is true. Negation is false. So therefore, this statement will be false because both are not true. Next, we come across P conjunction negation Q implies R. So it is if-then condition. It says P must be true, Q must be false, then only it is false. In all other cases, it is true. So here P is false, this Q is false. So this is both are false. So therefore it must be true. So this is here false implies false. So therefore it is true. So P is not true, Q is false. So therefore it must be a true statement. Next one, P implies Q implies R. So let's see now. P is true, Q is true, R is true. So let's see P, Q implies R. So Q implies R will become false if Q is true, R is false. Our Q is true, R is false. So therefore, my statement is false here. Next, let's see the implication of this with P. P is true. Again, P is true. The second one is false. So therefore, it is false. If then condition holds, that is it is false when P is true and Q is false. So it is true and false. So therefore, the result is false. F. Next question. If negation P and Q or negation R is a false proposition, then find the truth values of P, Q and R. So here, previously, the truth values of simple propositions P, Q and R was given. We are supposed to calculate whether the logical connectivity is true or false. Now here, they have given the logical connectivity between those three terms. They are saying it is a false proposition. The statement is false. Then what might be the value for P, Q and R? Let's see this now. So now they have given the statement like this. Is false. So we have a connectivity OR here. So OR is false when both the two statements are false. So what does this implies? This implies negation P and Q is false and negation R is false. So therefore, now let's see now. When is negation R is false? If R is true. Now, when does the negation P and Q becomes false? It is false if both the conditions are false. So therefore, according to this statement here, negation P is false and Q is false. So now, when is negation P is false? When P is true. When Q is false. Given. R is true. So we have got all the values for the propositions P, Q and R. So P is true, Q is false, R is true. So next type is negate the following proposition. So we have to check the logical connectivity here, whether it is true or false. Then we have to negate it. Here the first statement is given, P implies Q or R. So if I negate this, then it is negation of P implies Q or R. So this is how we are going to negate it. So we have a law called De Morgan's law here. So we are going to use De Morgan's law. So when you are negating the conditional proposition, for instance, P implies Q. When you are negating this, P or negation of Q. So we have to write this statement in the form of this because P implies Q form. So how I can write this? The first one is as it is or negation of the second one. So negation of Q or R. And we have one more De Morgan's law, that is negation of Q or R can be written as negation of Q and negation of R. So this is one more law. So again using this property, we can write here P or negation Q and negation R. So this is how we can negate each and every statement in the given logical connective statement. Next question. We have P and negation of Q. So negate this. So negate P and negation Q. Again using De Morgan's law, that is negation of P and Q can be written as negation P or negation Q. So if I write this, this will become negation P or negation of negation Q. So 2 times the negation is same as the original statement. So 2 times the negation is nothing but coming back to the same original statement. So this can be written as negation P or Q. Next, the third one, negation P implies Q. So how we can write this? Negation of negation P implies Q. So again using De Morgan's law, we have negation of P implies Q as P or negation Q. Now we have P here, write P as it is, that is negation P. Q is in the form here, so which we have to write this or negation Q. So next type, here directly the statements are given. We are just supposed to negate the statements. The first one is 4 is an even integer or 7 is a prime number. So now it is in the form of P disjunction Q. So when you are negating this, what is this? Negation of P and negation of Q using De Morgan's law. So therefore, 4 is an even integer or 7 is a prime number become 4 is not an even integer and 7 is not a prime number. So using the De Morgan's law. So what does it state? Negation of the disjunction says negation of P and negation of Q. So P is 4 is an even integer. So negation of P is 4 is not an even integer. We have or, it must be converted into and. Next we have 7 is a prime number. Negation of Q. This statement, if you take it as Q, it is not Q. So that means 7 is not a prime number. So the next statement, if 2 triangles are similar, then their areas are equal. So 2 triangles are similar P, areas are equal as Q. But we have here P implies Q, if then statement. So the De Morgan law says when you are negating the conditional statement, that must be equal to P disjunction negation of Q. So therefore, write P as it is. 2 triangles are similar. 2 triangles are similar. And if then statement converted to or, negation of Q. Their areas are equal become, their areas are not equal. Their areas are not equal. So like this, using the De Morgan's law, we can negate the given statement. So remember all the De Morgan's law, that is negation of the implication, that is conditional, is P or not Q. Negation of P and Q is negation P or negation Q. Negation of P or Q becomes negation P and negation Q. So using these 3 properties, we can negate any type of propositions. So in our next session, we will learn few more concepts related to mathematical logic. Until then, keep watching, keep learning and keep exploring. Thank you.